Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, we are from Universitas Abulyatama, Institut Sains and Teknologi AKPRIND Yogyakarta, Universitas Lancang Kuning Riau, and Geopolymer and Nanomaterial Research Center. On this occasion, we want to say thank you to committee for inviting us in International Conference on Engineering, Science and Technology. The title of our discussion today about influence of nanosilica and crystalline admixture on the short-term behavior of various underground geopolymer phase. I will divide our discussion into four sections. For the first one, I will show you the problem statement about geopolymer phase, its durability and the purpose of this study. And I will show the material and the preparation process of geopolymer cement. For the last one, I will show you the results about the resistance of nanosilica and crystalline admixture basic geopolymer phase in the underground environment. Nowadays, the demand of alternative cement-based material exposed to various environmental conditions has been the attention of many researchers. Foundation, sanitation network, and concrete pipes buried underground are some examples of construction structures exposed to aggressive environmental conditions. To increase the resistance to aggressive environmental impact on geopolymer, the matrix must be dense, and additional materials such as sulfate-resistant cement containing high silica and alumina is recommended. Recommended hydrophobic compounds, products based on silanes and silicones are recommended as additive. Nanosilica can reduce porosity and water absorption by increasing the calcium silicate hydride gel so that the geopolymer paste is denser. Crystalline admixture can also enhance the durability of cement-based material. Crystalline admixture will react with nanosilica and fray as forming insoluble crystal that fill the pores and capillary network in the geopolymer. Nanosilica was synthesized by salt gel methods. 100 grams of rice husk was reacted with 60 milliliters of 1 normality sodium hydroxide at 90 degrees Celsius by 1 hour. Then filtering was carried out and finally from the filtering process 100 milliliters of warm aqueous was added. This process solved sodium silicate, then 1 normality hydrochloric acid was added until the pH of the solution became 7. The nanosilica gel form was elevated to sand for 80 hours at room temperature before being used on the preparation of geopolymer paste. To prepare geopolymer paste, an alkaline solution, a mixture of 10 molarity sodium hydroxide and sodium silicate was made. The ratio was 1 and the proportion of composites of nanosilica and crystalline admixture used was 0, 3, 4, and 5% by the mass of fly ash. Fry ash, nanosilica, and crystalline admixture were mixed with an alkaline solution, then stirred for 25 minutes. After 28 days, the geopolymer paste was tested for its durability by burying it underground. The specimen was buried at 1 meter deep so that it had direct contact with the soil. After 30 days, the samples were taken and checked for their condition. This figure shows the change in geopolymer mass due to addition of nanosilica and crystalline admixture before and after burying. This indicates that the mass decreased and the grid mass loss occurs in the specimen without the addition of nanosilica and crystalline admixture. This finding showed that adding nanosilica and crystalline admixture to the geopolymer paste can withstand drastic mass loss. Nanosilica and crystalline admixture can hold pores from the influence of groundwater and the decay of organic material because silica and crystal from crystalline admixture can fill the pores. These pictures display the photograph of the specimens before and after being buried. These pictures show the visual change on the surface, especially on the Geo0 specimens, without the addition of nanosilica and crystalline admixtures, where erosion occurred on the surface. The erosion happened because groundwater could enter the pores through the surface. As for the specimens with nanosilica and crystalline admixture, the geopolymer was slightly damaged. Specimens without nanosilica and crystalline admixture shows a higher strength loss than those with nanosilica and crystalline admixture. The permeability of the geopolymer paste reduces the entry of damaging substance into the geopolymer matrix and increases the resistance to attack in aggressive environment. From this picture, the addition of 3%, 4%, and 5% of nanosilica and crystalline admixture in fly ash-based geopolymer paste can effectively reduce the attack rate of the underground environment. Based on the study results, this study verifies that nanosilica and crystalline admixture increase the durability of the geopolymer in the underground environment. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.